Hi and hello viewers. Today I am going to discuss you how to design a socket for using an hexagonal bolt. Normally, socket will have to withstand the torque given by the assembler or a tightener of the bolt. So there should be a wear and tear on the hexagonal bolt. So that much wear and tear you have to consider what dimension you are going to choose that socket. So for that we can design in the SolidWorks. Here click new part. Okay, the plane will be got to open. Click extruded boss and base button. It should be prompted to choose a plane. Click front plane. Here the sketch for future, it will be automatically go to sketch future. Click circle, place that in the origin. Just do it here. The unit is set for meters as a default. You can change it through going to document properties, units, to millimeter, gram and second. Okay, click OK. Then do smart dimension. This is needed to do for 24. Click OK. Sorry, this should be 25. Yeah, click exit dimension. Click exit sketch. Just select blind is sufficient. This the length should be 40. Click OK. Click OK. Now we created the solid part of the socket. Now we have to create a hexagonal portion in the face. Click extruded cut. Select the plane. Click the polygon. Select it as wherever you want. Click smart dimension. Click the point what it should be. It should be 23. Because why I am choosing 23 is to is that bolt, hexagonal bolt head length should be 20.8, because for 20.8 means that M12 hexagonal thread, M12 hexagonal bolt thread should be M12, means that the hexagonal head width will be 20.8. 20.8 means that socket I said already the tear and wear you have to see. For this dimension there should be a wear and tear that should be very minimum. That can be calculated in SolidWorks itself also. I can explain you in another video. Just go through what I am saying, and subscribe here and comment here. You can follow up here and ask your doubt below. Even though in this video I'm going to discuss you like how this dimensional all at all coming here. So this should be 23 is sufficient. Click OK. Click exit small dimension. Click exit sketch. It should be prompted this should be 12. Why I am choosing 12 means this hexagonal bolt head thickness, which means height is 11.2 something will come. So for that there should be chamfering and some location allowance we have to give, that tearness and also some clearance we have to give, so that the face of the hexagonal will not sufficiently touch that face inside the hexagonal extruded cut. So it should be 12 is okay. Click OK. Then you can see the part is created successfully. Click the bottom view. Sorry. Click the front view and click the back view. Yeah. click extruded cut. This actually I am going to do for the purpose of fixing this socket, or sorry, ratchet shaft going inside the socket. So the ratchet shaft dimension should be 10 mm. So 10 means that allowance we have to give side to side. 1 mm is quite sufficient, so 1 plus 1 it will be 12. 12 diameter is okay. Click OK. Then exit sketch. You can prompted here, this should be 20 is the depth where the shaft will be seated. You can see this spot is quite okay. Then click side view. You can see the side view very clearly. Click extrude cut. This cut I am going to do only for the purposes where the spring loaded ball in the shaft of the ratchet will be seated perfectly, so that only it will give sufficient torque to the socket. So just choose the plane, which plane you are going to design. This is a right plane. Okay, then click the line, just extend the line, click smart dimension, just do it for 10, click OK. Then click circle, take this end point as a reference for the circle, then do it. The shaft ball is 8 mm diameter, so it should be 8.3 or 8.25 something, because this should be fine. Why it should chosen as a fine means that hardened material can easily surfacely it will wear when we are going when we are involving such torque. So it should sufficiently withstand that material. All at all, it should be calculated vice versa, what type of the torque in terms of kilonewton acting on the ball. So for that circular part means that load will be carried uniformly distributed around that surface, a circular spherical surface in there, so it can able to easily locate. So 8.3 is quite sufficient diameter for the hole. Then click exit and exit sketch. Now just you have to choose the region. Yeah, we have to do another direction. Click through all for both side. Yeah, because there is a two holes we are going to provide. Even though some standard ratchet have a single ball inside to locate to give sufficient torque, but a customizable ratchet will give sufficient torque to the shaft only through two side, which means it can give sufficient torque by coupling that ratchet through the ball. And also that opposite directional force will give sufficient load and sufficient turning moment to the hexagonal nut, and also to the socket assembly point in that ball where the ball will sit. So click OK, no problem.